Hello everybody. In this video we're going to be covering solving quadratic equations. Now what do we mean by solving quadratic equations? Well, it's to solve equations that are quadratic. So for instance, if we have x plus 1 is equal to 0, then what we mean by solve is find x, right? That works. And then solving quadratic equations just means that we have a quadratic function here. And then we need to solve for an x that works. Okay, so that's what we're going to find. Or that's what we're going to do for this lesson. So, in order to solve quadratic equations, we need to know how to factor. And this is just a review. We've done this before. So let's look at the first one. Factoring for quadratic equation or quadratic expression with coefficient 1 with a is equal to 1. So again, you find two numbers that multiply to -6 and add to the coefficient of the second term. So the two numbers that multiply to -6 could be 2 times -3, which is -6. And then you have to make sure that those two numbers add to 1. Because that's the coefficient of the second term here. But that's -1, so that doesn't work. But by looking at this, I can tell that -2 and 3 would work. So -2 times 3, which is still -6, and then -2 plus 3, which is 1. So that works. So this means I can decompose this second term into these two. So what I mean by that is this expression is the same as x squared plus 3x minus 2x minus 6. Because 3x minus 2x is 1x. And then what we can do after this is just group by factor by grouping. Group by factoring. What's that? X plus 3 minus 2x plus 3. So I did this by just factoring out a -2 from here, and then factoring out x from the first set. So then you notice that we have x plus 3 and x plus 3 here, and then we can factor further, so it's going to be x minus 2. And then each of the x and the -2 had x plus 3, so that's why we're able to do this. Okay. So that's the factor form for question A. And for question B, it's a little different because we have a coefficient of 6 here at the very beginning, at the very front. So the only tweak or difference in solving this or factoring it is to find two numbers that multiply to not 6, but the product of these two. So first you get the product of those two, which is 36. So now you find two numbers that multiply to 36, but add to 13. Again, this coefficient of the second term. So two numbers that multiply to 36 could be 6 times 6, but that doesn't add to 13, so that's not it. The other one I can think of is 4 times 9, and that does add up to 13, so it's going to be 4 times 9. That works. Okay, so again, you use these two numbers to decompose the second term there. Again, we write 6x squared the same way. And then 13x is going to be equal to 9x plus 4x, right? These two add up to 13x. So we're allowed to do this. We didn't change the equation at all. And then we write the third term. Now we can factor by grouping. Okay. You can factor out a 3x because each of these have 3x. And then you can factor out a 2 here, x plus 3. And then you should realize that each of these have x plus 3. So what we're going to do is factor out an x plus 3 from these two terms. So what we end up with is 3x plus 2 x plus 3. Because the 3x has x plus 3 and a 2 has x plus 3. Okay, so this is the factor form for question B. Now we're going to go on to the investigation for solving quadratic equations. So consider this question. X squared plus x minus 6 equals 0. So I just want to first give you the distinction between equation and expression. So this here is an expression. The reason why it's an expression is because it's an expression that has terms, variables, numbers. Okay, it's different from an equation because an equation actually has an equal sign in it. Okay, so again, that's the distinction. So therefore, a question may ask you to solve this, right? You can't say solve x squared plus x minus 6. There's nothing to solve. You don't know what it's asking for. An expression. It's just an expression. It can tell you to factor their expression. Anyways. So here, now we're trying to solve x squared plus x minus 6. And then I can think of 3 ways. I can. Maybe you can think of more ways. But the 3 ways I thought of were, the first one is to just guess and check, right? That's one way. Why not? So we put in 1 as x and see what we get. We get 1 squared plus 1 minus 6, which is equal to negative 4, right? Negative 4. But that's not equal to 0. So that 1 doesn't work. That's out. Try 2. 2 squared plus 2 minus 6, which is, oh wow, got pretty lucky there, 0. So 2 works. How do you know if there's no other number that works? So we keep going. 3 squared plus 3 minus 6, which is 9 plus 3, 12 minus 6 is 6. And then 4 squared plus 4 minus 6, 16, 20, 14. See, this doesn't equal 0, this doesn't equal 0. Yeah, so you can see that the process becomes very long and very difficult to do if you use the guess and check method. So we're going to stop there and then look at the other ways, okay? How about this way? Graph the function. Okay. So let's graph and then find out where y is equal to 0. That makes sense, right? So if we graph this function and then see where y is 0 and then see where the x is at that time, at that y value of 0, so whenever it crosses this axis here, then that should be the answers, right? So to graph this quadratic, we need to use the table of values. So let's start at negative 2, because I really don't know where to start. So we put negative 2 in here, we get 4 minus 2, which is 2 minus 6, which is negative 4, negative 1 in there, 1, 0, negative 6, 0, we get negative 6. How is this possible? Negative 1, 1 minus 1, which is our negative 6, yeah. 0 is negative 6 as well. 1 is negative 4. And then 2 is 0. So if we graph this, we have negative 2, negative 1, 1, 2. And then we had mostly negative numbers. So we had, go by ones, I guess. 1, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Okay, let's see. So at negative 2, it's negative 4, so there's my point. Negative 1 is negative 6. 0 is negative 6. 1 is negative 4. And 2 is 0. Okay. So I'm guessing that the graph kind of looks like this. And the reason why I know this is because this is a quadratic equation. So you're going to get like a parabola figure. Okay, so we have one of the answers, which is here, at x is equal to 2. So that's one answer. And that's the same answer we got when we did the guess and check for solution 1. And then you can tell that the other answer is going to be here. But you can tell that this way of solving the quadratic equation is difficult as well, because you really don't know where to start. Like when I started this, I just chose random numbers to plot from negative 2 to 2. It could have been from like negative, I don't know, 100 instead. We still didn't get the other x value because we didn't continue with our table of values, right? It's just too difficult. So let's take a look at the other way, the third way of doing it. Okay. For this way, it asks us to reformat the left side of the equation by factoring. Okay, so you factor this. X x plus 3, x minus 2, right? Okay, that is equal to 0. So the right side stays the same, and the left side, it is just the factor form. So it's still the same equation. Then it says, then find values of x which would make the statement true. We have a statement here. What value of x would make this true? Well, if you put x as -3, then you get -3 plus 3, -3 minus 2, which is, I don't know yet. So this is 0, and then this is -5. So 0 times -5 is 0. Oh, that works. Great. So x is -3, works. And then we have another option at, let me write it here, when x is 2. Because if we sub in x as 2, then we get x2 plus 3, and then 2 minus 2, which is equal to, I don't know yet. This is 5, and then we get 0, which is 0. Perfect. So that works. So x is equal to 2. So we have 2 answers. Okay. Awesome. This is probably the best way. At most, you're going to get 2 answers for quadratic equations, and at the very least, probably 0 answers. You'll get imaginary answers, basically 0 in our case. Okay, so x is equal to 2 and x is equal to 3. It seems like solution 3, the way to solve quadratic equations, is the winner. So I would say, I would recommend solving it this way. I mean, any other way would make it, well, for sure the first 2 ways is going to make it very difficult for you, and it'll take way longer. Okay. You might be asking, well, how do I know that there's only 2 solutions at most? Well, remember what quadratic equations look like on a graph? Parabolas, right? This or this. And basically, you're finding out when y is equal to 0 when you're solving these. Okay, when you're solving these. Because I can replace the 0 with y, and then change the question up by saying, when does y equal 0? Right, that's the same thing as asking this question down here. So when does y equal 0? That's basically saying, when does it intersect with the x-axis, right? That's when y is equal to 0, isn't it? So if we have a parabola, the only possibilities are they cross twice, they cross once, like this, or they don't cross at all, like this. So at most, you're going to get 2 answers. There's no way to translate the parabola or stretch it to make it cross the y-axis, the x-axis twice, more than twice. So that's why at most you have 2 answers, and we got the 2 answers here. X equals 2 and x equals minus 3. Okay, so let's do some of these practice problems. You can try them on your own, pause the video, and then you can check your answers afterwards. Okay, so let's do this. We're going to factor this. Remember, we multiply these 2 together first because we have coefficient on the first term. I mean, a coefficient that's not 1 on the first term. So that's 36. Find 2 numbers that multiply to 36 that add to 13. We did this one up above, so it's 4 and 9. So this is going to be equal to 6x squared plus we decompose 4x plus 9x plus 6, which equals 0. And then we can group these 2 and then factor out a 2x for the first set, 2, and then a 3 for the second set. It seems like I've done something wrong here. 2x, oh, 3. Okay. And then you see that both these groups have a 3x plus 2. So what you're doing is factoring out the 3x plus 2 from both. Okay, so that's 2x plus 3. If you're confused about this part, just replace 3x plus 2 with a. And then you can see that you're just factoring out an a from both 2x and 3. Okay, so then we get this equation after factoring. Okay. And then we need to figure out when this is equal to 0. So we just need to make this 0 or make this 0. So how do we make 3x plus 2 equal to 0? Well, you just set yourself up to find it, didn't you? This becomes a standard two-step algebra problem. 3x plus 2 minus 2 equals 0 minus 2. 3x is equal to negative 2. X is equal to negative 2 over 3. So that's one answer. And then the other one is 2x plus 3 equals 0. So again, you subtract 3 on both sides, and then you get 2x is equal to negative 3, x is equal to negative 3 over 2. So that's the other answer. Awesome. Okay, let's take a look at the next one. A rectangle has dimensions x minus 6 and x minus 4, as shown here. If the area of the rectangle is 48, what are the dimensions of the rectangle? Okay, at this point, you're probably wondering what it's asking you to do. So why don't we just get the area of this, because the area is 48, right? So the area is 48, which is equal to the length times width, which you should know. What's the length here? X minus 4. What's the width? X minus 6. That's it. So then, after this, it's going to be very hard to find out, well, not very hard, but you're going to have to guess and check to find out what x's work to make it equal to 48. And the trick here is to not do that and FOIL this out first. The reason why we're FOILing the right side first is because after FOILing this, we can bring over or subtract 48 on both sides, and then we get a quadratic equation that we solve for 0. Okay, let me show you. So here 48 is equal to, FOIL this, x squared minus 4x minus 6x plus 24. And we simplify it a bit more, x squared minus 10x plus 24. And then we could subtract 48 on both sides. 4 minus 48. And this becomes 0, x squared minus 10x minus 24. Now, see this? You just set yourself up to answer this problem using methods you know. So remember the first step. Again, there's many ways to do this. You can either guess and check, graph it, or you can do it using the easiest method, which is to factor. So I can see that x minus 6, nope, that won't work. X minus 12 and x plus 2 works, right? And then you're finding out x values that make this 0 or x values that make this 0. And then x values that make an x value that makes this 0 is x is equal to 12 and this x is equal to negative 2. So these two work. Okay. And then let's revisit what the question was asking again. A rectangle has dimensions this. If the area is 48, what are the dimensions of the rectangle? If we have x is equal to 12, that's not the dimension of the rectangle. This is just x. So the dimension is, again, the width or the length. The length is given by x minus 4. But what's x? We got it here. So 12 minus 4, which is equal to 8. And then the width is 12 minus, oops. Oh yeah, the width is 12 minus 6, sorry. 6 given here, width, right? Which is 6. Okay. So these are the answers. Length is 8 and width is 6. Not these. These are just the x values, not the dimensions. And then you must be wondering, well, how about for -2? Well, let's try it out. So the width is x minus 6, which is -2 minus 6, which is -8. Okay, so we have a problem here. You have a width that's a -8 length. That makes no sense. So that's why we ignore this, and we just go with this, which means the only dimension that work is 8 by 6. And that's it. Okay, so that's the end of this lesson. If you have any questions, email me. Okay. I think the lesson was, I hope the lesson was pretty straightforward. If you have any other ways to solve for quadratic equations, please let me know. Okay, and then I'll see you next time. Bye.